Hi, everybody. My name is Cole Smith. I'm the Dean of the College of Engineering and Computer Science here at Syracuse University, and very honored to have here today Colonel Eileen Collins. She's author of a book called Through the Glass Ceiling to the Stars, the story of the first American woman to command a space mission. And she's also, I think, very importantly to me, of course, a Syracuse University graduate of mathematics and economics. So Eileen, thank you so much for joining us. It's great to have you here. I've also got here with us Dr. Natarajan Gautam, a professor of electrical engineering and computer science, and close to my heart, a specialist in operations research, and he's directing our operations research and system analytic program here at Syracuse University, a master's program. So Gautam, thank you so much for being here.
Thank you. Thank you for inviting me.
Of course. Eileen, I'll start off by just asking you about how you found out about the operations research program, because I mentioned your undergraduate degrees, and then you went off to Stanford University to study operations research after a little bit of time with the Air Force. So can you tell me how you found out about operations research?
Yeah, great question. Because I would not have heard about the degree operations research if it had not been for the Air Force. So I was interested in going on in my career academically, getting a master's. Because I was active duty Air Force, I was flying airplanes at the time. I noticed there was some openings to teach at the Air Force Academy, but I needed a advanced degree for that. So I started looking and saw that Stanford University had the operations research degree, which back in 1985, very few universities had that degree. But the Air Force had a need for people with degrees in operations research. And the Air Force does just a variety of things. They do systems, like they do logistics, they do supply chain. I could just go on and on with all the national labs and things that they do research in, that they needed people that could program and basically define the problem, write the variables for the problem, write the constraints, write the programs, and come up with ways to optimize a solution. And so I went really with the intention of fulfilling a need for the Air Force. So that's how I found out about the degree. And had I not moved on to teach at the Air Force Academy, I would have probably gone to Wright-Patterson Air Force Base, where that was at the time the what we called Air Force Materiel Command, where they did all the supply, logistics, etc., and many other things. I could go on and on, various places that the military could have sent me, but there was a need for that, and the military being on the leading edge of analytic in really, I want to say, be the best military in the world. Yeah. I ended up teaching at the Air Force Academy. I taught linear algebra. I taught the whole calculus series, but I also taught linear algebra, which is one of the foundational skills that you need to the programming necessary for operations research. And the Air Force Academy at the time was developing a degree in OR that was going to be in the management department. I was in the Department of Mathematics, but yet we had a kind of like a crossover. We had an overlap in the departments. Mm-hmm. So I helped them with building the foundation of eventually developing the degree. So that's how, I think that's the answer to your question, how I found out about the degree. I think that today there is still a need to get the word out to young people on what operations research is and how critical these skills are for, I could look at almost every industry in the country right now. And if you have the skills and a degree of operations research, you are going to be the first person that they hire, because these companies want people that can solve problems. And essentially you learn problem solving in a very analytical way, not to, I want to say, don't shrink from your problems, don't be afraid of your problems. Yeah. But this degree in operations research helps you define the problem in your mind and know different ways to attack it. So long answer to your question, but it's really, it began with the Air Force, but it's not just the military. It's everywhere across the world that needs these type of skills.
Right, that's outstanding, and we're really hoping to offer exactly that skill set at Syracuse University as we start our operations research and system analytics degree. I think one of the things that can be intimidating for students is not coming from, pursuing an operations research degree when your undergraduate is in something different. And yours was in mathematics and econ, and mine was mathematical sciences. Gautam, you were a mechanical engineer, right? So Eileen, how was it for you walking into an OR program where your undergraduate degree was a little different?
Yeah, that's another question that really sparks a fire under me because I thought first of all, I thought I was very well prepared with the mathematics and the economics. At Syracuse, in the economic degree back then, you could kind of lean toward the social side of economics, or you could lean towards more the analytical, mathematical side of economics. I took courses from both of those, but I kind of leaned towards, price theory and macro
Yeah.
economics, and I really liked the analytical side of it.
Sure.
So those two complemented each other very well. I think of them as the building blocks to what you need for operations research. I had a weak area though. Now, first of all, my strong area I thought was linear algebra. And the calculus skills I was good in, the linear algebra I was good in mostly because I took a lot of courses. The first time you take them, they're all hard. They're all hard the first time you take them.
Sure.
But if you keep taking more and more of those courses, they build on each other and they get easier as you go along. My weak area was probability. I think I only took one course in probability as an undergraduate. And when I arrived at Stanford, and keep in mind, it was 7 years between my undergraduate and my graduate degree. So in those 7 years, I was flying airplanes in the Air Force. So I was not doing any academic skills at all. So I went back to Stanford. I went back to get my master's. I was at Stanford. I took a course in probability they're on the quarter system. So my first quarter, I took probability. I was failing that course. It was so difficult. I felt like I jumped in at too high of a level, and maybe I should have taken an undergraduate basic course in probability over again. So this is why it lights a fire under me, because sometimes students will jump in, they're at a little too high of a level, and they say, oh, this isn't for me, I can't do it, it's too hard, and they quit the major and they go do something else. I am very vocal about not doing that. I think when students enter, you need to make sure that you enter at your correct level, because I really think some people learn faster than others, and some people are slower learners, and that's okay. If you think you're a slower learner, don't jump in at too high of a level, because it's going to eat you alive. So I really I ended up passing my probability course, but I look back and I think I jumped in at too high of a level. But I thought I was very well prepared in the areas of calculus and linear algebra. So those were courses I took at Syracuse: mathematics, economics, foundational. I don't want to discourage anybody from entering operations research, systems analytics based on my comment. I just think you need to make sure that you enter at the right level so you enjoy what you're learning and it makes sense to you.
Yeah, that makes a lot of sense. And I can definitely appreciate that comment too, especially that gap for being out for a while and not using that. It's going to be hard on anybody. Gautam, you are director, our inaugural director of this program. Can you talk about how this is constructed in a way to facilitate people coming in from different majors?
Sure. This program, has a so-called prerequisite of an undergrad degree in any one of the STEM fields, as long as the students have had courses in, like Eileen just mentioned, in linear algebra, courses in calculus, as well as probability and statistics, all these at the undergraduate level. And we also ask that students have some programming experience in some language or the other so that they know how to write a computer program. So these 4 skills, the good thing is that we will kind of reinforce them in the very first semester. We have them take this kind of like it's not really a bridge course as much as, a quick refresher, and then we will jump on to what they would need for the program per se. So we will spend the first semester that they're here catching up on linear algebra. There is a linear algebra course and a probability and statistics course and a data science course that covers all the bases that we just talked about. So that is the plan as far as our program is concerned. So it pretty much just goes off of what you just said, Eileen. But I also wanted to ask you a quick question, Eileen. So we were wondering, what would be, in terms of operations research itself, in the program that you took at Stanford, what are parts, or even afterwards when you worked, what are some things that you really enjoyed most, things that you remember and really love to as part of your operations research degree and career?
Actually, what did I love the most? Two things come to mind. And the first one is I really love the problem solving nature of you look at society, you look at the world that we live in. And I mean, I'll take a perfect example. Driving through a complicated intersection. There's one in Houston where it isn't just a cross intersection, but there were six entryway, and there were two traffic lights, but six ways to get into this intersection. So those lights had to be timed to get the maximum amount of traffic through that intersection. So you can think civil engineering problem, but it's really an operations research problem. How do you do the timing on those lights? You need data, so you need to know where's the traffic at what time of day. But that I found that fascinating. So I think I really liked the real world nature. And let me give you another example. Airlines. So some of the airlines have many different types of aircraft, different sizes, and they go to different cities, different airports. The traffic is like the number of people that fly on their planes varies depending on day of the week, time of day, maybe time of year. So you can actually write these big, I want to say, problem solving algorithms or whatever we call them today, methods of problem solving to maximize profits for the airline. And you got to define all those variables I just mentioned. What are the constraints? And you can actually come up with a solution. So we were doing things like that. So I like the real world nature. Now, keep in mind, when you start a program, you got to do all the basics. So some students think it's kind of boring doing the basics, but you've got to get those basic skills. And then when you advance in operations research, you can start hitting these real world problems. And the second part of the question, what did I like? I like the fact that we had a project at the end. So my last, I think it was like the last, I don't know how many months, but maybe 3, 4, 6 months of the program, we had to go work with a company somewhere and help them with a problem. And the company that I got assigned to, there were 3 students worked together as a group, was with a company called Fair Isaacs, who were located in north of Stanford. It was in Silicon Valley, somewhere up, I don't remember what city they were in, but Fair Isaacs is the company that developed the FICO score, FICO.
Oh, yeah.
And the FICO stands for Fair Isaacs Company. Honestly, I don't remember exactly what I did because it was back in 1986. It was a long time ago. But the fact that I was working with a company that developed the FICO score, I thought was kind of cool. And we helped them with some of their analytics in our, I want to say, our master's project. So I like the real world nature. So I want to encourage students to not get discouraged when they take maybe their first semester or their first group of courses. It gets more real world as you get to the end and you start doing more practical things towards the end. So thanks for the question.
So this is great. So that leads into another question about some of the fun uses of operations research and where you've been able to do this within your career. So I imagine that you're not solving linear programs while floating in space or working on probability or anything along those lines directly in space. But I would say that there's a certain culture of thought, like what you were referring to earlier in the interview. So can you tell me about your use of operations research in your career?
Well, I will say that I have used operations research, and I could give you a very long answer to this question, but I think what I'll do is give you a couple examples. You mentioned space. No, I didn't actually design algorithms when I was in space, but while I was training for my space missions, it was important for me to understand what was going on around me in our engineering areas, in our flight control, and our flight directors, which was really mission control operations. And I think a good example is something called Kalman filtering. And some of your listeners may have heard of Kalman filtering. It was something that we learned, I'd say we learned it more theoretically when I was in my master's program, but it was used in the space shuttle. And in fact, primarily on entry into the atmosphere at the end of the mission. So a space object has something called a nav state, navigation state, and it's defined by XYZ. So X is fore aft, Y is right left, Z is up and down, and also an X dot, Y dot, Z dot, which is what is your movement or your velocity in each one of those axes. And with some other, like there's a time variable and there's some other elements in this nav state. When the shuttle returns from space, it is very important to know where it is at every microsecond in time. So Kalman filtering was used to bring in all this data that we were getting from satellites and from stations on the ground. We got it from GPS, we got it from radar. All of this data was coming in, and the data had to be crunched in a way that you would come up with a nav state, but you also had to predict where was the shuttle going to be next. And this Kalman filtering would do that, and it would filter out the noise because you have scatter in the data as it came in and filter out the noise, without going into any more detail, which I don't think I completely understand it 100%. But when the mission control flight directors started talking about Kalman filtering, I knew what they were talking about. So there's many examples of this throughout my career. After NASA, I worked at an insurance company and bank, and I was working in their risk management department. And I say working, but I was kind of overseeing. I was a board member and I was overseeing what was going on. And because I had had my background in operations research, I was able to understand the risk management terms that they were using. Insurance is all about risk management. Even banking is about risk management, and understanding how they do things like, what are you going to charge this person for their insurance premium? Or what kind of a score are you going to give this? Someone applies for a loan, they have a financial score like a FICO score. Knowing how those are developed, knowing how they're used in risk management, as well as many other things when you do something new for the first time. Let me give you this example. I'll go back to space. The space shuttle program used something called probabilistic risk management, which is a very analytical way to define, what are the hazards? What is the probability this hazard will happen? And then you can assign a risk probability number to it. And then what are the consequences? How much money should we spend on this particular hazard to control the risk? All of those use methods that I learned in operations research. And I'm sure there's other industries that do, I don't know all of them, but I can primarily talk about the space, the insurance, and banking because I have experience there. I felt as a board member or as a astronaut flying the product that was designed for us by these engineers, I needed to understand what they were talking about. I needed to understand the language of the industry. And even if you don't know how to write a program for every single problem that might occur, knowing the language and understanding the methodology behind it is very important for a manager. If you are in a position of making decisions someday, how much money do we spend on this? Do we do it at all? Is it worth the risk? You want to understand what your experts are telling you. You want to understand their language. So I thought this was all very important to me. Am I going to fly this shuttle mission? Do I feel like this shuttle mission is safe to fly? Do I need to ask management to do something else? And again, I'm not an expert on this, but I think knowing the language and not having to ask them to explain every single word to me, I was better prepared. And I think that could be true of any industry, but operations research, because it crosses so many different industries nowadays. And I think I think everybody should have at least some basic skills in how, maybe even one course in operations research is something everybody should have if they plan on being a manager or a decision maker someday.
It makes perfect sense the way you put that. I agree. It just understanding what the tools are that are out there. You don't have to know how to go pull them off and do them manually yourself, but at least understanding the tool set that's out there is really important.
Gautam mentioned earlier the four basic things. I had mentioned three of them, but the fourth one that I missed was the programming. You don't have to know how to program everything when you get to a higher level in your company, but you need to understand what they're doing and what their tools are so you can ask them the right questions.
We definitely heard about many different ways that one could use operations research, in particular, whether it is in, like Eileen mentioned, in airline industry, or it is in banking, or it is in insurance. As a matter of fact, even in Pentagon, power grids, hospitals, Wall Street, and as a matter of fact, space too. So there's a tremendous number of applications of operations research, and I think students coming out of a program like the Operating Research and System Analytics here at SU have opportunities to go into a wide variety of fields. And I think this really brings tremendous value to a person, whether they're starting out or at a much higher level. Now, I'd like to ask Eileen a quick question, and in terms of what would be something that you would you give as an advice for somebody thinking about getting a degree in operations research and system analytics?
Well, as a lot of advice, I think I'd be happy to give. My advice may not apply to every single person, but I would consider, first of all, to seriously consider the degree if you want to graduate and have industry coming for you versus you looking for them. If they know that you have these type of analytical skills, you can pick the industry that you want to work in because there is such a big need. When I left my last position, which was with an insurance and banking company, they were looking for people with data skills, programming skills, problem solving, analytical skills. And they were just hard to find. So I would say seriously consider it. At least take the first semester. Don't jump in at too high of a level. That is very important because one of the crusades that I'm on right now is to stop students from dropping out of engineering and computer mathematical science programming, because what happens is they get in at too high of a level and they want to get A's, they're not getting A's, maybe they're flunking, and they switch their major. And I think that's a tragedy. I really do. I think that these young people, they want to be in these career fields. They want to be, it's their passion and they want to follow their passion, but they get discouraged because their grades are not good. And just because you were straight A's in high school or maybe straight A's in your undergraduate doesn't mean you're going to jump into the next program and be straight A's. It's just hard. Mm-hmm. So don't overdo it your first semester. I think this applies to master's programs also, because I did that in my master's program. I jumped in at too high of a level. I stuck it out because I pretty much had to. That was the Air Force telling me that's what my degree was going to be. And so I stuck it out and I did well at the end. So don't get discouraged, keep it up. And as you go through these programs, think about the real world, think about problems you face every day. I really think that, some people might think this is a stretch, but it's the honest to God truth. The way I live my life every day, which is I live a very high stress life. I'm doing a lot of things. I'm meeting a lot of new people. I'm doing things that are new to me, even at my age. And sometimes I overdo it. I have to keep like throttling back every once in a while. But I think the problem solving skills that I have learned through my degrees, mathematics, operations research, have helped me in my everyday life, along with what I learned in the Air Force as an Air Force pilot, because we do emergency procedures and we learn how to solve problems that way. I think that there's people, I see the world, people are faced with problems and they get scared. They shrink from their problems. Yeah. Mm-hmm. They either deny there's a problem or they'll go and, I say, play video games, because I do that. So, I mean, just like run away from your problems. And it doesn't have to be, it's okay to take a break from your problem. You have to take a break from your problems, but you should be able to look at a problem and not be afraid of it, mm-hmm. and say, there is a solution to this. I have some techniques that I learned. I'm going to try to apply those even to my everyday life. Personal, social problems that you have. I remember thinking I could write a program for that, or I could write an equation for that, or maybe I could write an algorithm for that. And for something going on in like, what's my career decision going to be? What do I want to do next? Define the variables, put a weight on each one of those variables. How important are they? Make an equation out of it. Now you don't have, and then you don't have to go with the answer, but I think just but setting up that problem helps you think through it, and it gives you a sense of control. You have some control over the things that are happening in your life because you have these tools that you've learned. So I think that what I've learned through math and operations research has helped me in my everyday life manage stress. You can't get rid of the stress, it's going to be there. But I think having tools to deal with stress is important.
Makes a lot of sense. So a softball question for the last question I've got for you, and that's just to ask you if you have any particular memories or a favorite recollection of Syracuse that you can share with us from your time here.
My first memory of Syracuse is football games. I'm sorry, it's not really academic, but
Oh, no, no, no. I didn't mean academic. I meant any memory. Yep.
I'm going to go way back
Mhm.
before they built the Carrier Dome, which I think was probably the early 80s, sometime in there.
That's right.
I graduated in 1978. We had the old Archbold Stadium, which was,
Yeah.
it looked like an open air Greek theater. I'm telling you, I remember sitting on these concrete steps in the freezing cold with these big parkas on, watching our football team play. And I never missed a game. I lived down there in Lawrence Hall. I lived on the 8th floor of Lawrence Hall, and the Archbold Stadium was right there, and we never missed a game. I also went to the basketball games because for a period of time, I lived out at what we called Skytop Apartments.
Yep. Mm-hmm.
I was out there my senior year, and we would just walk to the basketball games because they were at the field house right across the street from where I lived. So I would say I had those memories stick out in my mind, and I definitely do remember my courses. I remember where they were. Oh, I got to tell you this.
Mm-hmm.
I remember going to get my final grades. Back in those days, they posted the grades on the wall outside of the classroom. And believe it or not, it was posted by your social security number. Mm-hmm. You would never do that today. But they have the social security number and your grade. And I would stick around. I wouldn't go home until December 23rd for Christmas until I stayed at the school and got my last score. So those are some of my memories.
So Eileen, look, thank you so much for taking the time. Thank you also for wearing the orange the shirt.
Yes.
I think you shared with us before. That's STS-114. That's the return to flight mission. Is that correct? And the Syracuse basketball mug, which is absolutely on brand and on point for this discussion. So thank you so much for that. Folks, if you want to, we're very grateful. And to the audience, if you're interested in learning a little bit more about operations research and system analytics, our master's program, we're very happy to talk with you. Please just contact our admissions office and we'll get back to you very quickly in that. We're eagerly searching a broad spectrum of people who are interested in this degree. Your backgrounds can come from many different places. None of the three of us had an operations research degree walking into this, and we've been able to make it get by very well. So I encourage you to apply as well. Eileen Gautam, once again, thank you so much. I really appreciate both of your comments. This was a wonderful conversation.